This is the ShadeMFM programming tutorial. So in this tutorial, I'm going to assume that you're familiar with splat and ulam and movable feast in general, because this is really specifically just about how to do these things inside ShadeMFM. If you're not familiar with those things, check out the links in the description to read about that first. Okay, so when ShadeMFM boots, it boots into this view, as we discussed before, and on the left are the different projects. So by default, it just starts in the basic project, which is just a bunch of drag and res. But what we'll do right now is we'll make a new project. So first we'll open the projects directory inside ShadeMFM. So just there's a projects directory, and you'll see that it's mirrored in the application. So when we create a new directory, you can see the application picks it up immediately. So ShadeMFM is designed to be a live coding environment. So usually I just leave it open and then have my code editor or whatever kind of running concurrently, and then ShadeMFM keeps up and tries to deal with all the new changes happening. So we'll make a new folder called blob, and now we have a blob project. So we'll go inside the folder, make a new file. We'll call it blob.splat. And Windows complains about extensions, but just ignore it. On Linux, of course, you don't get any of that nonsense. So we'll load splat in as into whatever text editor you want to use. And I usually just pin my text editor on top of ShadeMFM, or maybe run it in a different monitor if you have a separate monitor. So that way I can code while I'm looking at the actual screen where all this stuff's happening. So in our blob element, we'll just say element blob. And here we need to switch to our blob project. And now it will load the blob project. So you'll see everything is empty. But actually, if you go to statistics and do show zero counts to see all the things that are zero, there's a whole lot of empties. But in addition to the standard drag, res, and all that stuff, we see that our blob element is already existing. So it doesn't have a symbol yet, it doesn't have a color yet, but it exists at least in the mind of the application. But it's nowhere to be found because the default initialization is just everything is empty. So in ShadeMFM, we initialize the world using a script. I don't have painting functionality implemented yet, so that'll come later, but for now we just initialize everything with a script. So the easiest way to create one of those scripts is to grab it out of the project, for example, basic. So we'll just copy paste that and put it into here, and you can see immediately the ShadeMFM has picked up that there's an init script and initialized the world. So if we actually look at this init script, you'll see we stole the one from basic, so it initialized it exactly how basic initializes. So you see inside, the init script is simply a function that gets called for every site. So at the start, for every single site, it will call this, and then whatever the result is, that will be the initial state of the simulation. And by default, everything is empty, so this just kind of does things on top of empty. So the way to read this is C is a C2D, which is a coordinate, so it's a signed coordinate that's coming in, and that's the coordinate of the site that we're initializing. And S2D is an unsigned size, and S is the size of the world. So in this case, it'll be 128 by 128. So we create an atom, and initialize it to empty by default, and then we throw some dice and say, well, 1 in 100, let's make it a drag instead. 1 in 10, let's make it a res instead. And if C, which is the site we're initializing, is equal exactly to the size divided by 2, which is the center coordinate, we'll make a new friendly fork bomb there. And that's this pink site in the center. So that's the initialization script. So we'll just hijack that. We actually don't want a bunch of drag and res, so we'll just delete that. And then instead of a friendly fork bomb, we'll make a blob. And so I hit Control S to save the file, and that change was picked up by ShadeMFM, and it immediately did the reset, understanding that we're going to reset the script. So now we can actually start coding our element. So first thing we probably want to do is give it a symbol. So we'll give it metadata symbol. We'll give it B, hit save. Again, let's see, it's picked up the symbol. We have a symbol now. Color, OX, I don't know, FA1. Okay, so we got our first error. When errors happen, they'll pop up right over your screen and it'll sort of say compiler output. So error in blob splat on line 1, color metadata OX contains non-hex digit X. Okay, so this is supposed to be a CSS color. So we'll just switch that to that. So that's a CSS rather than a C style color. Okay, so once the error is corrected, the compiler output sort of turns blue and happy and it says splat compiled successfully. And you can click OK here or close the window or whatever, so you can get rid of it. So the errors will pop up and go away, so you don't need to waste space on looking at, you know, a dedicated error region. So now we have a valid color and a valid symbol. So this is now a legit splat element, and we can hit run, and it's just sort of sitting there. That's because it doesn't do anything. So we will add rules, and the first rule we'll add is, you know, that's just, oh, wait a minute. So we have another error. So line 7, sentential form, blah is out of place, missing space in the first column. Okay, so spatial forms in splat, I need to start with a space on column 1. So there you go. It thought that it was GPU long because it was starting on the first line. So hopefully if you're familiar with splat, that makes sense. So by default, this is just a hold rule. We just don't do anything. But if you know how to make stuff move in splat, it looks something like this. So it says if we have an empty space next to us, which, you know, this is us, let's move us to that empty space and replace ourselves with an empty space. So this is kind of like a swap with empty space. And if we save that, you can see it's running. We can speed it up to see what's happening. So now it's going all the way to the left because it sees an empty space on the left and it goes there. And that's because the default symmetries are none. So it just goes into that direction. So we probably want symmetries all. And if we do that, now it's moving everywhere. So note that when I change the code, it reset my entire world state. This happens because as you change the code, potentially you might create new data members, you might create entire new elements, and the state of the board might no longer be valid. Like for example, if you had a bunch of blobs on the board and then you deleted the element entirely, you know, they're still in there, but now you don't have code for them. So by default, ShadeMFM will just blow away the board state every time you change code. But it can be convenient to be able to change code while the state is still running and not blow it away. But because that can be a kind of a sketchy operation, it's hidden behind this switch here. So you can click don't reset when code changes. And what that will do is now when I, for example, switch from, you know, symmetries all to none, it will keep the element where it was, switch the code from underneath it, and then, you know, continue. So I just switched it from none to all. And this is very useful for when you're tweaking rules. Just be careful if you do it this way. Your board may be in an invalid state, but you know, that's up to you as a programmer. So we'll keep it like this for now because it's fun to change things as they go. And we can always reset manually, of course. So, you know, we want to add a hold rule by default, since otherwise the element would get deleted. So let's try something else. So let's try, instead of when it's an empty, let's make something there. So that will create now fork bomb style behavior. So that's pretty neat. But actually, what else we could do is we could say, well, if there's 2 spots that are empty, why don't we make fork bombs far away? So that's kind of cool. You get the stipple pattern. And this is interesting because this particular board state we ended up with is an instance of what I was saying. Because we're reloading the code live, this is not a state we could have reached. So see, it makes this interesting kind of checkerboard here and then fat thing here. Well, that's because these guys all propagated using the original rule, and these guys are propagating using the new rule. So interestingly, if I reset the board, I won't get that same pattern because, you know, I don't have that rule anymore. So, you know, watch out for this kind of stuff if you're not resetting the board during code changes. So that's a really basic fork bomb, kind of messing around with it. Let's make another element. And in fact, yeah, maybe we'll just make it so that it stays a fork bomb for now. And then I'll do that. It's kind of fun to watch these bars kind of take over and stuff. So let's make another element. So let's take blob and we'll just copy paste it. And when you copy paste the file, you'll almost certainly get this error. And so don't be scared of this. All it's saying is because it's live checking the folder, it basically saw, look, blob copy splat, blob is redefined. It's basically complaining they got all these redefinitions. And that's because you have two of the same file now. And it's saying, well, you can't have two of the same element. So we'll rename it to flob. Of course, it's still complaining because even though it's renamed, the code is all the same. So we'll open up flob and we'll rename it to f flob, and now the compiler is happy. So we'll take it away. So the compiler is happy, but the symbols are the same. Probably in the future, I'll make the symbols fail compilation as well because they really should be different. Let's change the color, let's change the symbol. Okay, so now we have flobs. And so for flobs, let's just make them kind of spread out. And now let's say, okay, instead of when I have an empty near me, let's make one more of me. Let's instead, you know what, actually let's keep that other rule because that was kind of cool how it was spreading out like that. And then we'll add another rule and say, look, if I just have one, if I have spots all around me that are empty like that, let's make a flob there. And so to make that happen, we'll say change f is a flob. Oh, shape of left and right parts don't match. Okay, so, and that's because it said, okay, they have three elements here, and it's saying, aha, yeah, this bit doesn't match on the right hand side. Okay, let's just don't change anything there. Okay, compiled successfully. Reset. So now we have blobs doing their checkery thing and then also creating flobs whenever they're kind of moving about. One neat thing would be also to move the blobs around, so maybe we should keep our original movement about rule. So now the blobs are moving around and the flobs are spreading. So that's kind of cool. And since everybody's friendly and they're only kind of replicating where there's empty space, they're not kind of taking over each other yet. So the first thing we'll try for flob is let's try to eat the blobs instead. So if we have an empty spot, let's see, why don't we do this? So if we say, if we're next to a blob, eat the blob. Okay, and we'll say given b is a blob. So you see all of a sudden rapidly all the flobs ate the blobs. But we could also do something more interesting. We can maybe not eat all of them immediately. So we'll say given b is a blob, we'll inject some additional code. So in ShadeMFM, we inject code just by adding braces. In regular Splat, you do this kind of dot notation, but in ShadeMFM, we just use braces to delineate that now we're doing GPU long code instead. And so what we could do is return random 1 in 10, let's say. So we're only going to actually succeed this rule random 1 in 10. So when we reset and run, it's not going to eat them as aggressively. You know, so if we random 1 in 1, look, it'll just eat them all entirely. But random 1 in 10, they have a bit of a chance to proliferate. So we'll see, run it at faster speed, see what happens. So this is kind of interesting because at the center, all the blobs get eaten because there's too many flobs. And then, you know, as it spreads, there's this kind of leftovers of blobs. But eventually they all get eaten anyway. So maybe we'll do something more interesting. Maybe they can't eat all of them. Maybe something happens when they eat a bunch. So let's add data, and we'll do unsigned, like 7-bit unsigned number eaten. So we'll add a data member to flob. So we'll break, and now if you hover over the sites, you'll see on the left-hand side, like I'll click on one of these. See, there's data, unsigned 7, eaten. So this flob has not eaten anything yet. So we'll reset the flob, run for a bit, break. So you see blobs don't have any data, flobs have unsigned 7. So what we'll do is we'll say, okay, here, you know, we'll say x, we'll say change x. So instead of just replacing it with empty, we'll replace it with x. And first we'll do the effect of replacement with empty by doing ew cur site new empty. So that's just the equivalent program, just with injected code instead. But instead we'll also say, okay, well, when we eat somebody, we will also do eaten add 1. So because the GP ulam, which is what's being injected here, which I'll talk about a little bit later, is not quite the same as ulam, as you can see. It's not object-oriented because there's no object-oriented support in compute shaders, which is kind of the GPU backend of this whole thing. So instead, it's kind of C-like. So for these members, you have these functions like add, mol, div, get, etc. So instead of doing like an object-oriented version, which would be like eaten plus equals 1, you kind of have to do this eaten add business. So check out the GPU programming guide to see all the differences. It's not too severe, but something to be aware of. Okay, so we'll do that, save, and then we'll reset and run. And then we'll kind of stop here. So let's have a look. So some of these, this guy ate nobody. Oh, this guy ate 1. This one ate 2. Some of them even ate a couple. Yeah. So what we'll do is we'll say, okay, well, what if eaten get equals 3? So let's say we ate a bunch of them. We will just like pop out, for example. So we do ew I new blob. So like once we eat 3, instead just explode into a bunch of blobs. So you'll see once it eats 3, it just explodes into more blobs. So now we have too many blobs. So maybe what we could do is we'll just do something like define num to burst is 3, and we'll do num to burst. Num to burst. So then instead, when it eats 3, it'll just pop out 3. So it's less dramatic. So once it eats 3, it sort of just keeps itself around. And that will actually keep all the blobs around. So that's a much more interesting dynamic. Maybe we can do num to burst like 10, see what that does. So now they'll eat a lot more, but then when they do eat enough, they'll burst. Oh, it's interesting. So maybe that's too many. Maybe 6. So one neat thing is you can just experiment like this because the code is live reloaded. So maybe that's too many still. Maybe 4. Maybe the blobs are just not propagating fast enough. Yeah, there we go. So now it's doing a little bit of popping. So we can go back to blob and maybe say, well, maybe we just replicate fork bomb style. So it's like much more blob around. So that's a very different dynamic. So yeah, that's programming in ShadeMFM in a nutshell. You can mess around with the rules, the colors, and everything. Obviously, I'm not going to go through every kind of language feature, but the basics are there. There are some limitations. For example, there's no quirks yet, there's no inheritance yet, no methods. Well, there's these kind of methods to access member variables, but that's about it. Generally, if you hit something that's not supported, the compiler will tell you about it. So for example, if you say something like given x stuff, it says expressions via colon are not supported yet. So you can kind of like work, it tells you even sometimes how to work around it. So you could do something like that. I mean, I'll still complain because stuff isn't legit. So, you know, it's decently robust. There's still features coming, but I think it's quite usable. Lastly, I think it's worth checking out the architecture of this whole thing just to understand what's happening behind the scenes, so you can kind of get a better mental picture. So basically what this whole system is inside ShadeMFM there's a splat transpiler. So it takes your splat files, which we've been hacking on, puts it through a transpiler. That turns it into GPULM plus boilerplate, which is really just GLSL shader code. GLSL is the shader language, the C-like language for OpenGL. And that GLSL code will go through the GLSL shader compiler, which is, you know, part of your driver and your graphics card manufacturer's driver. So it might be an NVIDIA compiler or AMD compiler. So it's a little tricky because the errors might be different there. And then it turns it into GPU microcode, which, you know, we don't care about. Generally speaking, you know, as a user of this thing, you should really only care about kind of this bit. The splat errors we've been seeing pop up, that's coming from the transpiler. So it catches a lot of the stuff. But if your injected code, for example, your GPULM injected code, that won't be caught by the splat transpiler because it doesn't really understand GPULM. Any errors in there will get caught by the shader compiler. So for example, if we open up, you know, this injected code and, you know, switch this I to a K, you're going to get an error. It's going to say error from GLSL compiler, flob splat line 22, undefined variable K. So generally these errors will be pretty good to understand, but now you know that if it's error from GLSL compiler, it's almost certainly in the injected code. So in those errors, you know, they could be more kind of cryptic, like if you do something like that, like syntax error, unexpected dot. There'd be more, you know, C-style errors, but that's what that means. So that means that it passed the splat compiler, but the shader compiler was unhappy. The GPULM language is really just a thin veneer over the GLSL shader language. So it's just a bunch of macros and boilerplate to make it valid GLSL. So if for some reason you're interested in that stuff, you can have a look. If you go under compiler debug and just kind of drag this window out, you'll see the input to the compiler. This is the splat transpiler. It's just a bunch of the concatenated files. These are all the files we've been working on. And then the output is going to be GLSL shader code, which looks very C-like, but you'll see there's sort of quite a lot of code. But it's decently well commented, so if you have a look at fork bomb, you know, for example, it'll tell you, hey, this is the rule. Here's the actual GLSL code that it generated for this rule. So it's readable if you know what you're looking for. So all of the different functions and things will be in there. So for example, the flob code that we were just working on, you can kind of find it. You know, there we go, element flob. So it has some macros for the member functions. It has some, here's your injected code. It says injected from file, blah, blah, blah. So you can read this stuff if you're interested, and even look at the abstract syntax tree for the actual splat code. So that's kind of neat, and it has all the spatial diagram parsing in there and stuff. So if you're curious about the compiler itself, you can look at that. And you can also dump the compiled code if you want to send a bug report or something, or you can even recompile the code. You don't need to do any of that. Basically, the ShadeMFM will look for changes in files and it will automatically recompile the code. and it will also try and forward any errors from the GLSL compiler. If anything goes wrong though, this is kind of handy to know about if we need to debug things together. These are in there. All right, I think that covers it.